Welcome back all. Uh, okay, so I hope the audio is audible to all. There's no issues with the audio, right? And you are able to see the screen. Yes. Okay. Thank you. Hey, good morning. So hope you have seen the first day of session, and today we will be having the orientation session 1, which will primarily discuss on what would be the complete architecture actually. In the sense, see, as I said in the earlier session, we need to understand the complete software architecture in order to know what are the areas where we need to do the security testing and what are the vulnerabilities, right? So for today, we will be I'll be letting you know the entire how the complete architecture looks like on a high level. We may not have the detailed discussion, but just wanted to brush up what is the actual software architecture looks like. Okay, so when we say the software architecture, right, it's as simple as this. We need some data, or there's a sense of, there's some purpose for which we will be looking at some data. So say a simple example in any company, let's take Facebook itself. So Facebook, the purpose of Facebook is to have a social media kind of environment where you share your activities, photos, videos, anything to your friends, and it is viewed by the ones in your circle, right? So you see something. So where do you see that? That is called as the client. Okay, and when you and something, the data that is available may not be present in the physical system where we are accessing it. Instead, it is stored in a database or in some server. So that is called as a database server. And the way you communicate between this client and database, that defines the client server architecture. All right. So now if you see the evolution, right, earlier we were using majorly mainframe systems. Okay, it's based more on terminal based systems actually, where you just have to give the valid address of the mainframe system, and you will have to communicate it. But the problem with mainframe system is you don't have a good GUI. The graphical interface is not that great. So that's where the need of personal computers arised, and Microsoft became an instantiate because of that. And from there, the need of connecting between multiple personal computer systems arised, and the data needs the need of storing data in a common place arose, and that's how the client server architecture came into place. Now again, the client server architecture, we have 2-tier, 3-tier, and n-tier. So from a simple architecture point, we have the client process, server process, and the middleware. Okay, so the client is something which we see in the front end. So it can be an app that is installed on our system, or it can be a browser that is present on our system, or it can be any POS machine that is present on your system. The POS software that is present on any of the, it can be on a POS machine, tabs, etc. Right? So this acts as a communication link between the end user to the server. So that's what a client is all about. Now, if you start using any system, right, you will be knowing the limitations or the advantages of it. Now, if you start knowing the disadvantages of it, the only way of doing it is creating some protocols or creating some logics kind of thing. That's where the need of multiple what do you say, 2-tier, 3-tier architecture literally came into picture. Okay, so now if you see the diagram, this is the client machine. A request goes through the network and it reaches the server, and from server it goes here. So this is a typical client server computing environment that is present. Now the limitations of it is, say suppose there's a regular data that is being accessed at the client, and every time it has to hit the server, right? So it's a problem. So a repeated data or redundant data is being sent through the network, and there's a lot of traffic that is going in, and that in turn reduces the performance as well as decreases the speed of getting the data, right? So that's the way we say the thin client server or fat client or something like that. So these terminologies came into picture, where they again divided it into presentation logic, business logic, and the data. So presentation logic is something like you see on the front end, right? So they are simple functions which will help you to get the data of that particular system itself. It need not search for the entire data. So simple example is when I click on data withdraw, the money withdrawal function in the ATM, I'll be allowed only to check the system, backend system will check the amount, and based on the amount that we give. 1 second, please. Sorry, I had a bad throat. So based on the amount that is present in my savings account, the amount will be whatever is the amount I have asked for withdrawal, it will validate. So what is it happening? It is not checking the entire system. So that's what that is one of the advantages of having a presentation logic. Now, when we say business logic, it's the next level to the presentation logic. So, what are the validations that we are doing when I'm withdrawing withdrawing money from the ATM? It will verify whether the amount is present in my savings account or not. So that's the business logic, right? So if you say something, or if you pass any information from the client, it should go to the actual server or the actual database server to validate the business logic. So that's the intention of having three different functions in a client server application. Now what does it mean from security testing point is, these three areas are the ones which will define the security testing test cases. So from a simple point, let's say on a high level, I'm just giving an example. What could be a presentation logic test case in terms of security testing? So in the ATM machine, when I say there can be multiple accounts. One can be a savings account, one can be a current account. Now, as soon as I enter in, swipe my card, it should show only for me either the savings account or current account for which I am subscribed to. It cannot show anything else, right? So that's your presentation logic test case. Now, from the business perspective, what is the user type and what sort of user he is? So based on his type, what should be shown on the presentation layer? So that's the business logic. And the data is what can be if an invalid password is given, or what is the amount, if the amount that I'm withdrawing is more than what is present in my account. That's the data level validation. So that's a simple test case from a client server application point of view. I mean, from these three functionalities perspective. All right. So far so good. Any questions? All right. So just let me know if the pace is too fast, or if you have any questions, just interrupt me in the middle or just ping me so that I'll slow down. All right. Okay. So a typical two-tier architecture, it can be on there's a client and there's a web server, and you have everything communicating either by LAN, WAN, or internet. Okay. Now, how does the advantages of having this is, it's very simple. All right. So there's a direct communication between what is expected from the client to what is present or available in the web server. So now think like this. When you click on google.com, you get the Google link where it will ask for the search button or whatever is the default landing page of Google is. Now, if I click on something on the search button, what will it happen? It will search on the, it will send the request to the web server through internet where the Google servers are physically located, and it will get the response based on that. Now I change the search criteria. and I searched for something else. Now after doing that, I came back to the old search technique. I mean, so search what do you say word. Now what is it happening? It has to go back to the web server again, right? Instead of, that's the problem with the two-tier architecture. Now that has been resolved with three-tier architecture, where you have something called as cache memory on your system, and then there's some business logics that are applied with the browser as well as the middle application. All right. So what is it happening? Some redundant data or the regularly would you say validated or requested data will be physically stored in a cache memory, and that will be retrieved. It's a simple example, but there is a larger, or this what do you say, that the purpose of having a three-tier architecture, it's a bigger debate actually. So at this point, let's not confuse you, but the current just wanted to give the difference between the two-tier and three-tier. All right. So the only difference between two-tier and three-tier is the middle level. The middle layer is a bit complex, or what do you say? It has an extra systems where it has a web server as well as an application server extra added to the two-tier architecture. So web server will guide you. It acts like an uh, would say a middleman between the client as well as the end server. It can be a database server. One second. It can be a database server or it can be a web application server. All right. One second, please. Sorry. So now a simple thing, as I said, a web server will come into place where it's just like a cache memory. Just simple way of understanding this is, it will act as a cache kind of thing where a regularly or what do you say, revisited kind of concepts will be stored, or it will guide something like that. Okay. Now from security testing point of view, so the more the applications or the more the servers that are getting into the system, the more number of ways of system getting under scan will is the possibility, right? So there's a vulnerability chance at each point of this multiple nodes. All right. So now, how does this is this apply to the security part? Now, simple thing is, there's a lot of communication between these multiple systems, right? And multiple systems communication has to be very secure. Okay, so that's where what do you say? That's where there's an every chance of security threat. Now, simple example is when I send a response through internet, so this communication should be secured. Now, how does it happen? This is a simple, say suppose this is a simple web application. Now, this is a browser through internet. So, internet, it can be a wireless one or it can be a wired one. Now, if it is a wireless one, so how does it communicate? What is the authentication process? So that's one area of security testing. Now, if it is a wired one, how does their authentication happen? Now, the second, this internet is on, whether it's an internet or intranet. So if it is within intranet, only the users that are present in our system or in our in the respective intranet office can only have an access. The external person cannot have an access. So the if it is a token based authentication, or if it is an A key based authentication, how does that happen? Or if it is just a plain password based authentication, how does it happen? Okay. Now there is a web server here and there is an application server, right? So there is this concept called as single sign-on, where the username password that we enter at the client will be same when I access the multiple systems. So suppose here in the application server, I have a database, multiple databases, or I have multiple file systems. So for all these folders or all these database applications, if the same single sign-on being used, then in any of these areas or any of these layers, if there is a vulnerability or if there is a chance of getting the logs or information about that particular user, then based on the single sign-on concept, you will have a single same username password, right? So it's very easy to access the other applications also or other servers also, right? So understanding the entire flow or the entire nodes or applications that are present in the system is more important. That actually plays a key role and in understanding the system or the security testing at least. So far so good. All right. Now in multi-tier, right? It's the next level of three-tier actually. Now if you see, right, the only yeah, so Ram, are you going to show how to test in each layer? Yes, ideally speaking, yes. So we will take a real-time example when we do the actual training from the next first or second, right? So that point, we will be showing a simple application and we'll try to analyze the entire architecture and we'll do the security test. All right? I'll just show you that. Now, what's a multi-tier architecture? So now these days, right, everything is being split into multiple systems. If they want to do the load balancing, so no, so before load balancing, they want to define multiple systems for their dedicated purpose. So simple example is there's a web server and there's an application server. Web server will on a high level will handle the whatever is on the front end or the business logic. Simple. It's a simple way. From the application standpoint, it will have the what is a multiple screens or multiple pages. How do you integrate them? How should the business logic should flow in? Okay, and how should the flow be actually? This web server is more of the front end or whatever we see. Now this is more of the integration between the multiple systems. It can be a database, it can be a data warehouse, it can be a file system. All right. So how does it what do you say, route the things that will be on the application server? Say simple example. Now, if you see, we are all also including a database server that's already a defaulted one, but there's something called as transaction server, which will, which again is doing a part of application server, like the load balancing, something similar to load balancing, right? So if you see, there are more than 2 or 3 application servers or servers that are coming into picture. So this is in real time we are using the multi-tier architecture. So that's how the evolution came from 2-tier, the problems with 2-tier to 3-tier, and then now to the multi-tier. The only reason for this having multi-tier architecture is they want to split the work. They want to reduce the burden on a single server. Now this again is gives a opportunity, or this again arises the problem of security, right? More the servers, the more the authentication process, the more the chance of a system getting under attack. There's a chance of attack. Now the next one is the cloud computing. So people will now they don't want to manage everything, and they're just moving every of the infrastructure or software or anything. I mean, the software on as a service which is available on cloud, or it can be an infrastructure as a service on the cloud. So infrastructure is something like physical, the servers or these what do you say, the storage elements or the apps that are physically located in some, not the apps actually, the storage or data and the servers are located on cloud, or someone is hosting that. They will be maintaining they will do the maintenance. We'll just give the software. Okay. Now this is infrastructure as a service, and software as a service is something you don't have your software, you are just giving the code that is present on the cloud and people are accessing it. Now this is again, there's a lot of chance that this can be a security threat again. So we are relying on someone else who is hosting your infrastructure as well as software, right? You're just accessing it through internet. Okay. There's advantages and disadvantages with cloud computing, right? So you're relying on someone else and you're relying upon someone else to maintain your software and infrastructure. Okay. So this is one another what do you say, software architecture we have. So you want the in-depth details about this cloud computing, or this is fine? I suppose that people understood it. All right. Now let's understand the basic networking concepts actually. So we have this LAN where a local area network, which means you have multiple systems in your in the office, and you want to communicate between these systems. So that is LAN. Now you have a branch office, and you want to communicate across the branches. So that's WAN, wide area network. Now you have some remote systems, okay, and end users resides anywhere else in the world, and you want to communicate to your server. So that is done through the internet. So that's the basic understanding about the computer network. Now, again, I don't want to confuse at this point, but there is a lot of security testing in each and every area of this, right? So I just wanted to give a glimpse on everything. Yeah, ideally, yeah, Ron, you are right. Should show firewalls in that diagram actually. But today's session is more on the concepts of the software architecture. I'm just giving the high level everything. When we do it in an actual sessions, right, we'll have a detailed description. All right. Yes, but yes, I should have included it here. Do you show how to test a networking? Ram, the purpose of this session is to give a glimpse on all the areas. Actually, it's just how to do in each and every area of the software environment. So yes, from the networking point also we will let you know, but not in an in-depth way. All right. It's just that we are covering all the sections, not just networking. Okay. But in the coming sessions, right, we will add all these courses. Now, now when we say people start accessing it from the remote, right? So how do we do it? It's through the internet. So we all know about this, but just wanted to brush on these concepts. Okay. So now how do we do it? We just open the browser, that's our client, and then we'll click on www dot and something, what is the URL, and then we'll click on OK. Now if you see uh, if someone, I mean, if you see the evolution, right? Earlier it was just www dot something, Now then came the HTTP dot something, and then the HTTPS. Now we are using HTTPS. So what is that it is happening? Why are we evolving to these? Why are we adding the extra words to the browser link? Extra links, extra words to the links. The reason being, right? If you start working on any of the system, you will understand the limitations, or you will understand the problems there, right? So in order to overcome them, or resolve them, we start doing the concept called as internet protocols. It's just the a simple way of saying is it's a form of etiquettes. So how do you perform an action between a server that is present in a remote location and to the end users, right? So what it does is it will define how do you communicate from the client to the server, or how do you handle the traffic, or how do you define the bus area, or the what is how do you define the sequence of what do you say, when we are doing multiple users are communicating to the system, how does it define the sequence where for which system should be served first. So that's where the LIFO or FIFO, last in first out, or first in first out concept came, right? And then how do you handle the errors? So that is defined more in the internet protocols. So IP, that is called as IP. Now a simple communication has 7 layers. One is the physical layer where we see, then the data link layer, which defines the flow of the messages. How do you control it? How do you control it? Okay. And then is the network. So whether it's a LAN, WAN, or internet. So how does the communication should happen? Then is the transportation layer. Transportation layer will let you know wireless or wired one, or it's a Bluetooth. So based on the concept, how does it happen? Then the sessions. Sessions will define, so a single stream cannot happen, right? So you break it into bits and pieces. So each session, each package will be a form. I mean, multiple packages will be form of a session, and then how it transfers. So this is a. I mean, it's a vast area. From at this point, so we have these 7 layers, and then again the presentation layer. So these packets should form into a logical form. So that should be shown in the front end, right? Simple example is, if your network is not that great, the Gmail when you log in, it looks a different way. You have a slow connection one, and a slow connection where the internet is slow, and the normal one, right? So if you see, both the UIs are different. So why is it so? Because the flow of packages is slow there in that particular situation. That's the reason the front end also looks a little uh, uh, vivid actually, or it doesn't look that glossy or that good actually when it is a slow internet connection. So that is dependent on the session layer and the presentation layer. Now the application layer is something you are directly communicating to the server. So from the server's point, so from the client till the server, we came to the applications layer. In the application layer, it will communicate to the respective application server and then get the data. So how does it communicate? So every layer has a security threat, or security testing is available. So when we do the network level testing, right, we will touch base on all these points. Okay. Now, what is a HTTP when you see from the what do you say, URL point? Okay, so HTTP is Hypertext Transfer Protocol. As I said, the IP, just now we discussed on the internet protocols, right? So the next level of that's the part of internet protocol is the HTTP, which is widely used, or which we are generally using it. But there are many other protocols which we in real time we don't see it actually. A simple one is, still there are many applications or many organizations, still they are using the command prompt to communicate between the multiple servers or multiple folders or file locations. In order to simplify it, just like how the mainframe system became extinct and the personal computers came into picture, right? Similar way, communicating between the multiple folders through CMD command prompt is became extinct, and that's how the web browser or the apps or the client servers came into picture. The clients came into picture. So in order to communicate between these applications, the simple way is HTTP. Now the problem with HTTP is it's a bit less secure actually. Um, we just say it's very less secure, but the problem again is we are not in the on a high level. We are just discussing it. We are not going in depth, right? So at this point, I may just please note that HTTP is a little not that great secure. That's the reason we came in the concept of HTTPS came into picture. The simple way of letting you know the limitations of HTTP is, say suppose we are communicating between one server to the other server. Okay. Now the communication happens by the response, or there's a time limitation that is not set. Say suppose I have to communicate between the Google client to the Google server. Now, there's no way where the response time limitations can happen, or you cannot set the response. Earlier it was like that. Now the problem has been resolved with HTTPS. A simple example. And then when you break that, right, if you see into the if you see the backend code of what an HTTP link gives is, it has an header which is uniform. Or simple way of telling you is, it's just like when you enter a password, you these days we see the asterisk symbol. Earlier it was not like that. We could see the password in the password how to say password text box. So simple way of understanding HTTP is also that. So what HTTP does is, it will not encrypt your messages that is coming, that is or are communicating between the client to the server. So there's every chance of security attack there, right? So it's a plain text kind of thing. The plain text goes to the server that communicates through the network, and you get the information. Instead of that, even if you encrypt that, then there's a less chance of getting it security attack. That's the reason they came up with the concept of HTTPS. So that's the primary difference between HTTP and HTTPS. So if you see any web application or any URL which is still using HTTP, which means they are not upgraded. All right. The second simple way of letting you know is the firewall concept. So everything when we have a detailed description, right, we'll just let you know. But just understand that HTTP is not encrypted and HTTPS is encrypted. All right. So I'm actually done for today. So if you have any questions, just let me know. Actually, there's a lot to discuss, but at this point, I don't want to confuse you all. So I just want to give a high level description on what all are present in a software architecture. Okay. Yes. So when we have a real sessions, right, we are going to cover everything in depth actually. See, I mean, I understand that there will be a lot of questions on how do we do it. But see, let's do it as a step by step. See, a simple thing is, if you don't know what are the areas where the security attack happens, we cannot write a good test cases, or we cannot write the good test plan, right? So we should understand the complete system, then only we can do the actual or good security testing. There are many areas, there are a lot of ways of learning it, but what in my personal experience or my personal opinion, learn the system first and then you know what can be done actually. All right. Yes, thank you. So any other questions, please? OS will also be covered. That we will do it in the next session. Tomorrow session we will be handling it. Okay. The All right. Any other questions, please? Okay. Looks like people are not having it. Okay. Sure. Sure. I'll share it. Okay. See, the problem with this concept is it's a it's a wide, and it's a lot. There's a lot of areas that we need to do as part of security test. It's not as simple as the functional testing. Okay, and it's more complex. It's more. It needs a lot of understanding about the system. Maybe at this point it is a bit confusing, but at the end of the session you will have a clear picture about what is to be done in the security testing. The market is really good. The opportunities the opportunities out there in the will keep on increasing. One simple example is Intel at this point is having a lot of requirement for security testing, and it is not able to find people out there in the market. Okay. Yes, Ron. As you said, right, SQL injection. I mean, in the first day session, we have discussed about it. So we will be doing on SQL injection. From XSS point, I'll try to brush up, but I mean, I am not, what do you say, sure that we will be handling this. Okay. I may not, obviously the problem is I have done more on SQL injection. I know a bit on XSS, and cross-site in scripting also I have done. So I'll be handling this, but I'm not sure whether we can have an in-depth discussion on that. All right. But from database testing perspective, security testing perspective, the plan is to do on SQL injection, because that's the core of all, right? This will help you in getting the complete information. The database is the core for everything. So it will have the connections to, it will have the logs of the connections between multiple systems. So our primary focus will be on SQL injection. And regarding the penetration testing, yes, it's a part of the course. We'll be handling that. So in the last site, right, I have shown you the multiple areas where we'll be doing the testing. Okay. Uh, or at least this course will be handling that. So from that point, penetration testing, SQL injection, and then passwords testing is the primary focus for this in this training. In the coming trainings, we'll add all these the other areas. All right. Um, no, we will be using the burp tool actually, Ron. Yes, the OWSAP is something. It's like the protocol. It's just like the internet protocol is there, right? So from the security testing also, it's one of it. So yes, we will be handling that. Okay. Okay. Ram is asking what is PCI. PCI is peripheral component interface. It's just like you the hardware that is available, right? So how do you communicate? How does the connections happen? So that is what PCI covers. Ron, no, Ron. From the Firefox Stamper data, no. See, this session is more on the basic concepts and how do you, what are the areas that will come under the test. Okay, not more on the tool perspective. Again, from the Wireshark point, see, again, from the testing, it's again a different, altogether a different training it happens. I just want to give you an understanding about the areas where we need to do the testing. This session is more about it actually. Okay, Ram is asking about the compliance DCI. Hmm. Okay. Uh, I'll okay, Ram. I think I will have to have a debate on this now. Yes, I understand we have to discuss these points, but from the compliance part, we have what do you say? Multiple compliance techniques. So DCI, at this point, I don't have an idea, but I'll try to let you know. Okay. In the network testing, right, on the PCI DCS, yes, we'll cover it. Okay. So looks like more everyone is interested on networking testing actually, network-based security testing. All right. Yeah, the more the online transactions happening these days, the more the need of security arises. Yes, PCI will is more on payment cards, right? So it will handle that. Yes. Okay. Actually, okay. Ron is asking how about certificates. So we have multiple test security based certificates actually. CPT is the one which many of us actually primarily focus on, and then there are compliance based certifications also, and then CSTA for the starters. CSTA is a good one, and then from the testing point there are others also like CEH, CPT, GPEN, or but from see it again depends on the area that you are more interested on. See, if you want more to be on the testing point, then CPT is suggestible. If you want to act as an independent consultant, CPTC is a good one actually. Uh, so it all depends on which areas you want to progress. Oh, from the okay. See, again from the socket, I mean SSL point, right? I understand we have, again I'm reiterating it. These all will be covered actually. I mean in the SSL point. Actually in the slide I was supposed to show you, but then again I overlooked it. But this will be handled in the coming sessions actually. The problem is we just have half 1 hour of time. So I at this point I couldn't have shown you, but that was in the cards actually. Okay. All right. Anything else? See, the encryption, decryption, everything will be discussed in the coming sessions. Okay. So whatever is the PKI or SSL certificates, everything we will be handling them. Okay. All right. So any other questions? All right. See, I just want to give a heads up again. This particular training is more about the basics for the starters actually. I know these all concepts have to be covered, and we will be covering them, but let's go it as a step by step. uh, for the benefit of others also, we will handle them slow and steadily. All right, but we assure you that we will be handling all this in the training. All right then, see you tomorrow at the same time. uh, if you have still any questions, please just let us know. We will be happy to answer them. You can mail us on our what do you say, the regular website, or I'm sharing you my personal email. You can post your questions. I'll be happy to answer them. Thank you all for joining. Good night and good day.